idle down on our Project Super. But now I'm dialing in the carburetors for good combustion air. The gauge you saw in the beginning of this segment, you saw the air-fuel mixture ratio indicator. And what I'm doing is I'm dialing in each one of the carburetors slowly but surely to make sure that we're running a little bit on the rich side. Not too rich, but I'd rather be rich on idle than lean, because leanness comes with great daily heat and potential engine damage. Richness, worst case scenario, you would foul up plug. So, and as I adjust them down, I'm starting to see my idle fuel mixture ratio come on in. We're basically looking for somewhere in the area of 12 to 13 parts per million on idle. And then it changes on full throttle, but for now, all we're really trying to do is just get this car a little stable. Okay, so right now I'm sitting at a pretty erratic idle. And you're going to hear the carburetors pop and suffer. That's just them adjusting to their new conditions. And as I start to bring in the fuel, my needle starts to get down closer and closer to the air-fuel ratio I'm looking for. And there is a fine line, because you can bring them in only so much before your transitional circuit, progression I should say, suffer from the fuel transfer. So you really got to find that sweet spot, and you can't get there after dialing it in. Then it's time to start looking at your idle circuitry to see if the jetting you have on your carburetor is appropriate for the motor. So, for those of you who really want to start wrenching on your own stuff, that's a great idea. But I want you to be aware of something. If you're going to start doing some of the brake work, the brake lines, you need brake line wrenches, and this is why. Brake line wrenches are basically a six-sided wrench that grab more of the nut. And the reason it does that is because the nut is it's a soft aluminum and it's very easy to strip, so you need to grab more surface. Don't use your regular box wrenches, okay? You're guaranteed to ruin either the fitting or you may have to replace the line if you have a problem. These brakes have been on these cars as long as they have and never been serviced or haven't been serviced in years and years, like in this case. You're not going to be able to get that off with the regular wrenches. Brake line wrenches are the only way to go, okay? So, with that said, we pulled the brakes off. They're over in the parts washer now, getting cleaned up. We got new pads coming for them. The pads that were on this car were all the way down to steel. In fact, they're all the way down to where this has a huge lip to it. And if I turn these, they're going to be out of spec. There is always, I shouldn't say always, there's generally the spec tolerances on the edge of the rotors. In this case, they aren't, because this is so old and it rusted over, you wouldn't be able to read it if it was there anyway. But the thing of it is, these rotors are already fairly thin. And they're deeply grooved. They're grooved because the pads have no pad on them. It was just literally metal to metal. Okay? We really didn't want to do this. We didn't want to replace these if we didn't have to. We were just going to put them on the sheet and we were going to turn them. The reason I wanted to do that, this particular style of 1600 brake is not a cheap rotor at all. These are fairly expensive rotors, so I'd rather just turn these and save them and save the customer a couple of bucks. That's not going to happen in this case. So that's where you're kind of at a crossroads, or an opportunity, I should say. This is where, if you were potentially thinking about upsizing your brakes to a 2-liter brake package, not a bad idea, assuming you have all the components to do that. If you don't have the components, very expensive idea. Great idea nonetheless, but an expensive one. In this particular case, we're just going to leave what we got here. Because again, this is just a car that's going to be an enjoyable street car. We will upgrade it as we go. We've already upgraded substantially with the suspension kit that we put on this. We put a package that is significantly lower than stock with an improved Tony yellow shock. We're going to have an upside sway bar we'll put in as soon as we get the fittings for the front and spring pins. Effectively, this car is going to be, albeit a quick street car, it's just going to be a street car. As we get more and more familiar with what the customer plans on doing with it, we'll make changes along the way. Okay, so it's just one of those things. If you're buying a car, and again, the whole premise of this was bringing a car back up that's been sitting a while. If you're doing something like that, the brakes is obviously one of the very first things you should tackle. Okay, in this particular case, the brakes automatically had to be flushed because this car hasn't moved since 1985. So brake fluid is immensely hydroscopic, which means it absorbs a ton of moisture. Okay, so we know that automatically the brake fluid would have been contaminated. So the fluid's getting pulled out. The rear is already done. We put that limited slip in there. We used the 91 Spider rear Otte brakes that were on that limited slip. We just cleaned them up and put pads in them, and it's ready to go. We're waiting on new rotors to come in. Unfortunately, because it's the unique style 1600 rotor, it's an expensive rotor. Can't avoid that. The brakes are getting cleaned up now. We're going to get them serviced because when brakes tend to sit, they tend to either seize up or the hydroscopic situation happens and rust starts to develop on the piston. So if you haven't tackled it, what typically will happen is if they work at all, the first time you step on them, they don't release because there's a ridge of rust on the piston that doesn't allow the piston to go back. So we're going to find out shortly whether that's a problem or not. What we're going to do is we're going to put them back on here. We're going to put brake fluid in the car. We're going to pump the brakes. And we're going to get that piston to move. If it seizes, we should be able to compress it back and get it to free up again, okay? If it becomes somewhat of a problem, we're going to stop and we're going to rebuild the brakes. So we're kind of rolling the dice because we have to spend time and labor to do that. But if we can save it, it's going to save him quite a bit of money. If we can't and they have to go out and get rebuilt, well, it's just the way it is. Okay, so here's the original brakes off that car. They look to be in fairly good shape. We already started cleaning them the other day, but now we're getting close to where we need to start making sure they work. So what we did is we did a little bit of initial cleaning, not only on the outside, because you got to think about this for a minute. These brakes back then, the brake pads were generally made with asbestos liners in it. So you got to assume that this car sat so long that it has that very same problem. So what we do is we're going to do an initial cleaning on it. We're going to get down into where the pistons are. We're going to clean that area out. Just kind of generally make this a little bit safer to work with. Okay. We're going to try not to scrub around the rubber of the boot too much because chemical cleaner like this does a great job of kind of wearing out that rubber. So anyway, we're going to clean it all up. And we're going to put it on the car with no pads in it. And we're going to start seeing if we can't get fluid, not only to move through the piston, but get them to free up a little bit. Okay, so I'm basically using a simple C-clamp to push the pistons back before I put them in. And the nice thing is they are moving, so I know that they're going to be nice and free when the new pads and everything are on, so no rebuild needed. But here's my deal. When I press this out, I'm seeing some seriously brownish black brake fluid. That means that it is definitely a compromised fluid. So even though we're going to be purging these brakes and putting in fresh fluid, there's no reason to have that in there. So by the mere idea of just compressing these pistons back in, we're getting all that fluid out anyway. So we're just saving ourselves a little bit of grief when the new pads get in. Okay, so we're getting ready to change out these rotors on this car. The reason we have to do that is because these are beyond a measurable correction. In other words, the groove on the top from the pad just cutting away, and by the way, when we finally pulled the pads out of these brakes, they were frozen. But when we finally pulled the pads out of it, there was no pad. It was a metal on metal contact. So you got significant gouging all the way through on the rotor. If I were to put these on a turn and cut them down to a smooth, usable level, the rotor would be way out of tolerance. What does that mean? Well, it means technically it's unsafe, but more so it means that the rotor will not handle any development in heat. In other words, if you're braking on it, imagine as you're going down a hill, you're pumping the brakes a few times and slow the car down. Those are going to heat up and they're going to warp almost immediately. So effectively, you can't really use them when they're outside spec. You're thinking, okay, no big deal, just change out the rotors. Here's a replacement rotor. The rotors for some of the 105 1600 series cars are incredibly expensive. I mean, like race brake expensive. A set of brakes for the front of this car will set you back over 500 bucks just for the rotors. So if you're doing all this stuff on your own, that is the time you start thinking, well, where is my money best served? It could potentially be on converting the entire car over to a 2-liter setup, or a later series 1600 where the rotor is a different style rotor and it's easy enough to address that. But these early series 105 rotors are, again, fairly pricey. So always think forward if you're doing this stuff on your own. If you're doing this on your own time, your own dime, you know, think about being able to upgrade those potentially. Normally we would like to do that, but actually, funny enough, we're trying to do this in a budget-minded way. For me to do a complete conversion on this, we got very expensive very quickly. Though these are absurdly expensive and very hard for me to justify the price of, it is still by far the better way to go compared to completely converting this over to something else. It sucks, it's expensive, but effectively it's the ideal way to go in this particular case. I'm telling you this, so if you have to deal with this yourself, you have the opportunity to think about maybe this is the time you take advantage of upgrading. You know, $500-600 bucks will probably take you quite far down the road on getting yourself used 2-liter conversion that you potentially bolt on your car for yourself. So anyway, we got the new pads, we got new stainless steel brake lines instead of the old rubber ones, and we have the new rotors. We're going to put all that in. Okay? I'm pulling the pin on these brakes, but I'm looking at the castellated nut and it's moving really easily in there. So that's actually a little bit of a concern, because though you don't want them overly tight, you definitely don't want them to where the bearings are allowed to float in and out and move around on them. That will certainly mean there was most likely excessive bearing wear happening. We'll check them out and make sure they're safe. And by the way, at this point in time, this is when you repack your bearings. You definitely want to make sure you're using disc brake grease. The reason you want to make sure you're using disc brake grease is because it's at a higher temperature tolerance than just regular. Shouldn't have been that easy to take out. They seem to be okay, so I'm not going to worry too much about them. We will clean the brakes up and we'll repack the grease, but effectively I think they're going to be okay. Trying to be as kind as possible because I want to be able to use everything associated with the hub. Okay, so effectively all we should have to do is unbolt the old rotor from the hub, bolt the new rotor back on, and bolt it back in place. But with that said, the bearing and the grease cap stayed on the spindle. So I'm going to have to get those off carefully as to not damage them, because I want to reuse them if possible. If they're worn and just don't work, then if they're still good, we're going to clean them up in the parts washer. And then we're going to just put new disc brake bearing grease on them, pack them up tight, reassemble the system, and put it back on. Okay, so we put all the bearings and the actual hubs in the parts washer, and we'll clean them up really good. Now there's literally nothing on these. If you rotate them and you don't feel any real notchiness with them being very clean, then they're most likely still okay. In this case, we know they're okay. And that turned out to be for all the bearings. We're going to put some high temp disc brake grease on them, but we also clean up the hubs. When you look at the races inside the hubs, races are what the bearings rest against. When you look inside there and you look at the hubs and you look at the races are really clean. You can see that there's no marring or unusual effect to them, unusual rubbing effect I should say on them, then they're also equally still okay. So the other thing is again, this is working on the premise that you're pulling a car out of long-term no use. When we pulled these hubs off, we found that all the grease that was impacted on the bearings and inside the hubs had absolutely no elasticity to it. It wasn't very grease-like. It was more like almost rubber. So the thing of it is, had we not done this, those front bearings in this car wouldn't have lasted very long at all. So it was a good thing we decided to do this anyway. So now we're going to go ahead and pack the bearings. We're going to put a little extra grease, not only in the hub covers, but also side the hubs. The reason that is as this thing starts to heat up, that grease is going to move around and it starts to wick, and it's going to move in and out of the bearings. So it's always good to have an extra source of grease to keep those bearings lubed. Okay, so we're going to start assembling our new rotor onto the old hub. And again, all the bearings are in good shape. We just need to thoroughly clean them. Now that they're thoroughly clean, you got to really pack them really well with some new bearing grease. But now that we're going to bolt on, the rotor to the hub. So we're going to put a little bit of anti-seize on it. A little bit goes a long way on these guys. While we were at it, because we changed this differential out to a limited slip, we also changed out the one non-standard rotation lug bolts. So this way, when this car is back on the road, all the lug nuts will be the same type of thread pitch. Okay, so now, alright, so got to have our locking tabs in place. And I'm just going to get one or two threads going on it. That's all I'm going to do. And then we're going to put a little more anti-seize on the next one. Again, putting anti-seize on these, I mean, basically at this point we're doing for serviceability purposes. A little bit later I'll measure this rotor, and I'll measure it against the one that was on the car so you can see the difference of how much rotor is not there. Remember, when you put these locking tabs back on, you got to bend one side of it so the threads can't back out over the bent portion. And when we lowered this car, I got pretty frustrated. The reason being is when we took the old spring perches out, once again, somebody had used equivalent to, in American Standard, grade-5 bolts holding up some of the spring perches. I can't tell you how concerning that is, because though we don't know the history of this car, because we're spending so much time working on it, we kind of are inheriting previous work done to it. And that's a little alarming, because had we not known how to read the quality of the nuts and the bolts on this thing, we could have potentially put the suspension back on using grade 5 bolts. Why is that a big deal? Well, grade 5 bolts just don't have the tensile strength that a grade 8 does. And remember, in metric, a grade 8 is called 10.9 and we stamped on the bolt. Whereas if it says 8.8, that is the equivalent of a grade 5 US bolt. So anyway, in this case, it became a little more alarming than normal, because I know the gentleman who owns this car. I know he has 2 sons. I know he's looking forward to these boys driving around in this car. Could you imagine if those spring bolts sheared? It'd only take one, because once one snapped, it's going to defer all that energy onto the other ones, and they're going to snap, and it's just going to bust away. So make sure you know everything about those bolts when what you're using. One down, one to go. Okay, so we're going to try to cover a few things, and hopefully it doesn't bore the heck out of you, is the bottom line. In the evolution of ignition systems for a car, we really shouldn't put the mindset in place that ignition systems add horsepower, because really that's not the idea to look at it. The best way to understand a better ignition system is that it's maximizing the potential of what you have, okay? Case in point, this is my car, the ever constant evolution, and I have a pretty massive 2-liter motor in here. It's got big cams, it's got big pistons, it's got big everything, and it's a pretty stout motor. Now, because of the cam's duration and its general lobe profile, it was very aware that it would be most behoovant to have an ignition system in place that I can sustain the burn rate on the spark and control the amount of burst. So what we did is we elected to go with a really high firing ignition system. This motor justifies it. Okay, so that's what we went with. Now, this is where it kind of gets a little interesting, and it can get potentially a little dicey for some people to understand. This is an MSD system, the MSD distributor, MSD coil, MSD ignition module, and an MSD timing controller. Okay, this is a rather complicated system for the sake of spark burn. Okay, with that said, this is all built for a Ford 4-cylinder 2.3-liter motor. Okay, they're very similar setups as to the Alfa. The only thing you had to do is you have to modify the length of the shaft. Just a little bit needs to be milled off, not hard science. And you need to change the distributor gear drive that connects to the oil pump. That's it. And then you effectively have something that is reasonably priced, fairly easy to install, and really reliable as far as the ignition systems go. So that's what we put in here. And I'm really happy with what I've done here. But there are a number of different variations out there. There are just simplistic, like a Patronic system, that it's literally just a good efficient burn on the distributor, and that's about it. And you also can really start to think about high firing spark plug wires and things of that nature, but the relationship of all those things need to be relevant as well. For example, this right here is a really complicated system with a special inductive solid core spark plug wires. Okay, but when you have something like that, you have to put in what's called a noise suppressor. If you're running any other electronics in the cars and you don't want to pick up that noise from the system, you have to run a suppressor. So I have a suppressor in this. In other words, there's an awful lot of homework that goes along with these things. Now, with that said, one of the other options out there, and this is being set aside for a future motor that we're going to build for me, but this is another one. This is the Electromotive, extremely high firing system. This is such a high firing coil pack that's on this that if you were to put your hand on it while it's firing, you could potentially do some serious damage to your heart or even potentially kill yourself. So this is a serious system that comes with a great deal of danger associated with it, but the power is there and it's a great system. Now this is fairly similar to what I already have in my car now. It comes with its own timing control module, and the nice thing about this is everything's right there under the cap, so you can adjust the timing. But it's also a crank trigger actuated system. In other words, it has a sender that picks up the magnetic distortion off the trigger wheel, and that's how it distributes power to the spark plug wires. With that said, there is no distributor in this type of system. You put a cap in where the distributor was, and that's it. Okay, this is a really cool, very modern setup as well. And we're going to use this on a motor that we're going to be building fairly soon. It's going to be an exceptionally powerful motor. And again, because the potential power of the motor justifies the ignition system we have. But we're going to start focusing back onto the Julia Super project, and we're going to explain what all this means and why that is in a second. Okay. Just wanted you to get familiar with some of the potential packages out there you could be looking at doing if you're looking to improve the performance capabilities of your motor. Okay, so effectively what's going on is we have, remember, this car is built on the concept of a reasonable budget. So we just have Petronics ignition inside the distributor, nothing crazy, a regular Bosch blue coil, and then we're running on some really nice wire wound spark plug leads. And we're running the GK B7E's spark plug, so it's a fairly good performing spark plug in relationship to everything that's going on here. But ultimately, all I'm really trying to do with this tool is make sure that my timing is well within what I'm looking for, so I can start tuning the carburetors. You have to have a motor that can maintain its idle and that can go through its progressions in order for you to be able to really set the carbs. And we're going to talk about that much more here in a few minutes. But I kind of wanted to refer back to the engine analysis system here. You might think you probably can't afford one of those, but believe it or not, they're really cheap. This is because this is old technology. There is a million of these still out there because most shops are starting to fade away from these because these don't work with electronic ignition systems. So with that said, the modern cars with their individual coil packs and all the things that are going on there, this thing doesn't do much for you. But on a vintage car, you can do a lot with these still. This comes with quite a bit of stuff to it. There's your tacked well set up right there. There's a volt ohm meter there. It comes with a timing gun that sits one of these drawers. You just pull it out. It's automatically energized when the system's up. You can check individual spark plug leads. You can check a million things with this, and so it becomes an immensely valuable tool, especially when you're in the vintage world like we are. And if you look around on like Craigslist and whatnot, and be willing to drive a little bit, you can probably find one of these for a couple $100. Believe it or not, something this cool is very much available for a couple $100 if you look hard enough. Anyway, back to our situation here. Okay, earlier in the video you saw me use a tool. It was this tool. Okay, this is an engine gas analyzer. In order for me to get these carburetors dialed in, I have to be able to make sure that a couple things are happening. One, the car has to be able to run efficiently on its own in order for that to become a useful tool. Secondly, I need to be able to make sure that if anything, that these carbs are running a little bit rich, more so than leaning out. If it's running rich, yeah, you can usually foul plug. Yeah, you get a little sooty gas exhaust. But effectively what you're not going to do is you're most likely not going to glaze the rings and create damage to the motor, because when a motor's running lean, it tends to run very hot. Sometimes you'll see exhaust headers crack when they're excessively hot gas is coming out of it. That's called crystallization. That's when you look down inside of an exhaust header, for example, and you see like a white phosphorus effect on the inside of the exhaust. That is an exhaust that is running immensely lean, and that is a motor that is really, really hot. So we have to recognize that if we're running on a carbureted motor, there are basically 4 steps to a carbureted motor. Okay, I have an exploded view one here for you. And I realize this is probably fairly hard to look at, so I'll get closer. Okay, the system down here, this is basically where your chokes are coming from, okay? Meaning that the cold start circuit, not the chokes inside the carburetor. But anyway, this is where the cold start circuit's coming from. This is just nothing more than, let's just call it a floodgate for the carburetors, okay? And what I'm talking about here is that when you first pull the choke out, you're basically just allowing fuel on the engine's vacuum. As the cylinders are pulling in, it's pulling a vacuum through the carburetor, so it's effectively pulling fuel right through these chokes and dumping it into the motor. It is emulsified, meaning that it's went through the jets to be emulsified with a little bit of air so it'll combust, but effectively that is all it is, okay? That is an essential circuit, but that is not a part of the actual performance circuit of the carburetor. You have 3 more stages you need to consider. You have the idle circuit, and then from the idle circuit you have the progression circuit. The progression circuit is right here, okay? These are performance carburetors, so I have just literally 2 progression holes. Multiple holes mean that is a production carburetor, not a performance carburetor, and it was built for a very specific use, meaning on a very specific motor, a very specific manufacturer. And rarely do you ever get those to truly work as good as a performance carburetor. These are some DCOE 40s. Same thing's on this. So anyway, in those stages, again, you have the initial stage, which is just the chokes, or the cold start, if you will. You have the idle circuit, which is fuel that is emulsified, meaning it has air mixed into the fuel that's pulling through the circuitry. You have the progression circuit, which comes into play as the butterflies, that's these guys, as these start to open, they pass over the progression holes, and that creates a vacuum, so fuel mixture with air is pulled through those holes that are inside there into the motor. And then last stage, stage 4, would be literally the mains, the main jets. That means when this things are just about all the way open, the main jets are now pushing fuel through, and that is a fuel that is not only emulsified, meaning air was added to it, but it's also atomized, means it's a fine mist when it's working right. And that's where you get your best explosion circuit from, okay? That's how the carburetor basically works. Now, in the harsh reality of things, carburetors are never ever going to be as good as fuel injection. It's just a harsh reality of it. It's a system that needs absolutely perfect harmony to get its most efficiency out of it and its performance. This can be a tricky thing to do, okay? So much so, though, even when we have carburetors sent out to get restored, we still have to use the gas analyzer to make sure that they're working great with the cams, the valves, the pistons that we have in a motor. So much so, this gigantic toolbox is nothing but carburetor parts, top to bottom, bunch of parts. I have circuit jets in there, I have all sorts of needles and seats, everything that needs to get carburetors dialed in. Okay, so if you're sending your carburetors out to get restored, a good restorer is going to want to know a few things from it. He's going to know not only the size of the motor, okay, he can do a general build on it, he can't do a fine-tuned build on that. He would prefer to know the cams you have in it, the size of the pistons, potentially the stroke of the motor if possible, the size of the valves. These are all things that are relevant into him selecting what he's going to put in his carburetors to make them match the motor. Now we have a couple of basic templates in which we build these motors under, so there's a ton of information out there that most carburetor builders will build to those specs. But if you have something that's excessive to the standard builds, he needs to know those things, because a good guy that really knows what he's doing with carburetors will be able to fine-tune those carburetors, so you have very little problem with them when you both want to go. Even with that said, you still need to be able to make sure that the motor is running efficiently and potentially, especially on a fresh motor, more rich and less than lean. A lean can cause a lot of motor damage, a richness not so much. It can give you some headaches if it's excessively rich, but it won't necessarily destroy the motor, okay? So that's where we're at in this case, all right? So we're running carburetors on this. It's a you know, obviously a budget-minded build, but that's where we're at, and we're gonna get that dialed in. Gas analyzer, timing, engine analyzer, I can really kind of get this set up where it can be a very efficient running motor, and I know that we won't run hot, or should I say lean or rich, on any one particular carb. Which brings me to my last example. That right there is also going on that future build that you just saw the electric motor stuff for. I have a set of these. These are TWM throttle bodies. A lot of people seem to be attracted to the carburetors. To them they look somewhat sexy, and I have to agree, carburetors do tend to look fairly sexy. But here we have fuel injection that looks like a carburetor. And what these are, especially more so, is these are built so I can run them on an advanced built Spica fuel injection mechanical system. So that future 2-liter we're going to build is going to have these with a very advanced Spica fuel injection on it. And that's really going to make a special existence, because it's going to have a vintage look to it, but yet it's going to be a very, very high performing motor. The nice thing about fuel injection that you just cannot get out of carburation is the smoothness of the acceleration, the easier starting, just the general well-being of the motor tends to be much greater at times on fuel injection versus carburetor. Now don't get me wrong, you can get a carbureted motor running silky smooth and great, but you can never really compare to the greatness that sometimes fuel injection can deliver. I'll make my point. I used to really be big into TR6s. one of my very first TR6s I ever owned had the initial, I think they're Strombergs or SU carburetors on it. The car ran very silky smooth on those carburetors. I thought I was going to get clever though. I went and put a triple set of Webers on it. Not really having a mapped out layout for those carburetors, it took me a long time to get those carburetors to even come close to running as good as the simplistic, smaller carburetors that were originally on that motor. So upsizing carburetors to a motor that's not prepared for it makes no sense at all. It's actually just detrimental. Setting up carburetors to work well with the motor you have shouldn't be warranted on the size of carburetors as is what the motor's capable of handling. Okay, to the point, in my car, I got a fairly large set of 45s on there with really big chokes inside of it, meaning that motor is more than capable of handling an awful lot of CFM, that's cubic feet per minute of air going through it. This motor, not so much, although this is a very good performing 2-liter, it really doesn't warrant having 45s on. So we have a really good set of 40s on this. So there's a lot of things you really need to keep in mind when you're developing your motor, okay? Gigantic carburetors don't necessarily mean a good thing, okay? They really need to be matched to the motor. Whatever that is, it is. Okay, something that's starting to become a little bit of a pet peeve of mine, and that is when we take in a project that somebody else did some of the work to, and for whatever reasons may have not been aware of some of the potential hazards they were creating. When we first started changing out these springs and the shocks and the sway bar in this car, we started to, we always try to anyway, pay attention to what was used on the suspension points. When I mean, in this case, the spring perches. Here are a few of what we found. There are effectively 4 on each side, a total of 8 bolts holding that spring perch in. Okay, 5 of them in this case were these, and these are in metric 8.8 hardness coarse thread, when in reality they should have been 10.9 fine thread, which is one of these. Now, what is the big deal about that, you're probably wondering? Well, I've said it a few times before and I'll say it again. A 8.8 metric is the equivalent of a grade 5 in US, whereas a 10.9 metric is equivalent to a grade 8 in American. Now, why is it such a big deal? Well, here's the thing. Like I said, 5 of the 8 bolts holding this in were these. I happen to know this guy. I know him fairly well. I know he's got kids. I know they're looking forward to driving this car and pushing the limits of it. How bad would I feel that if these soft, non-hardened bolts broke? See, if one breaks, it puts that much pressure, an additional 25% pressure, on the other bolts. If they're grade 5, you're already pushing your luck. If one of them lets go, you're actually increasing the problem. Whereas the 10s, not so much that big a deal. Also, they're coarse thread. What's supposed to be on here is a fine thread. What is the big deal about that? Well, the fine thread, think about it like this. The more contact patch the nut has in relationship to the bolt, the more bonded the two are together, the more durable it is. That wasn't happening here. And just as much as you need to be aware of not only what is on the car, you also need to be aware of the thread conditions of what's on there. This is another one of the bolts that was on here. This isn't a criticism, this is just an awareness. When I pulled this off, I could see that the threading was very thin and wore out. You don't want to risk it, so you don't reuse it. So we use new ones. These are 10.9s, okay? This is a fine thread. They're gold cad, they're really, really hard, and we use aviation nuts. Okay, aviation nuts, there's a rule to those if you didn't know it. Technically, if you use aviation nuts, that's just the nut that you use in lieu of a lock washer, if you will. It doesn't loosen up is the point of it. But the thing of it is if you put that on, once you put it on that first time, technically that's supposed to be the only time you use it. If you have to back it out, technically you're supposed to discard that nut and use another one. That's the only way you can be assured that it still has its locking capabilities on the first try. So we changed out all the nuts on this and all the bolts for 10.9s with aviation nuts, put them on one time, and that's it. If you are going to be doing some kind of suspension upgrades to your car, thoroughly check the nuts and bolts on there. If they're all the original fine thread 10.9s, doesn't mean you should be changing them out, because the original factory hardware on these cars is actually quite good. And if you were to change those out for an exact drop-in, meaning the exact shoulder height and everything else, and replace it, that would be very expensive, because that hardware that's on there is already a really high quality hardware and it works well. If it's in good shape, reuse it. Clean it up if you want. Go have them re-oxidized if you need to, but there's no reason why you can't reuse the original ones. This particular case didn't have the original ones, so we substituted with these. This is a real safety concern. I have seen one of these spring perches let go. I've seen what it was. It was a sheared off bolt. It's nothing to mess around with, especially when it comes to your safety. Okay, so our project is starting to wind down. It's going to go live its life this summer as a family little cool shuttle, if you will. But we have the wheels out to the powder coaters right now. What we have going on this car are the GTA replicas, the 15x7s. Now when it comes to supers though, you can't just use the standard offset, which is a 29, ET29. You have to have two different offsets. You have to have the ET35s and the ET29s. Reason is because there is very little clearance on the inner fender of a super. Now we sent these out to go get powder coated in a different color. The person who owns this car wanted a darker color than the stock, bright aluminum that the replicas come in. So we're going with more of a charcoal finish, and it's a two-stage clear coat, powder coat, might I add, which is going to be pretty cool. We should have them back next week. And we're also running, in this particular case, a 195/60 15 tire. It's a Dunlop a Spec Star tire. It's a really good performing tire. And we have to be conscious of the tire sizing just as much as we do with the offset of the wheel, because again, you have very tight tolerances on the rear end of a super, especially when you start putting in limited slips, which change the shimming effect from left to right. So there's a lot of homework that's going to happen, basically where we're going to be going from here. Most likely we're going to have to take these discs off. We're most likely going to have to surface the front of them to create a little more drop-in space to make those wheels fit with any kind of room. It's just something to know, because you have the idea and the potential of running a really cool wheel like the GTA wheel on these, but the offset is a real issue. So if you are looking to change out the wheels on your car, be very aware of clearance on the inner fenders. Early GTs and Supers have a real big problem fitting wheels that will fit effectively almost anything else in the Alfa lineup. So anyway, if we have to mill the surface of the brakes and modify things to make those happen, we'll give you an update. But effectively, I'm hoping that the wheels, once they get here, we're going to mount them on new tires and just drop them on. That would be my goal. And with that said, entering into this video, you saw me dismounting some tires on our tire machine from a kind of unique 5-star wheel that goes on one of these Duettos that we have here. For a while there, we were getting an awful lot of magnesium wheels in just for the purpose of die checking them. That's something that I kind of want to make sure you're aware of. If you actually go and find yourself a real set of magnesium wheels, whether they are, you know, the Campagnolo, or if they are, you know, another kind of wheel that is noted to be magnesium, spend the money to have somebody die check them for you, because magnesium wheels are notorious for cracking. Okay, and to get them repaired, you have to find somebody who's halfway crazy enough to weld them. But there are people out there, especially near airports, because a lot of airplane parts are magnesium, and oftentimes they need to be repaired. So, and that can be expensive. But the thing of it is if you do end up investing in a set of magnesium wheels, be prepared to have them die checked before you write that check, because here's the thing: if they're cracked, it's a very expensive thing to repair. We have done, I would say in the last 10 years, we've probably done 50 sets of wheels, die checking them. And out of those, I would say at least 10-15% have definitely been cracked to a point where they were unusable, and the person had to pay to have that welded up. And like I said, that it's a very expensive experience to correct that. It's just an FYI.